Welcome to our lab exercise where we will be looking at displacement measurements. The displacement measurement instrument we will be looking at is the LVDT, which stands for Linear Variable Differential Transducer. It has a magnetic core with a shaft going through the center. The LVDT is supported in place by a stand and a clamp and is powered by a power supply AC voltage. In this experiment, the shaft will be sitting at the end of the cantilever beam to monitor the deflection due to load applied at the free end of the beam. As the beam deflects due to load applied, the shaft moves within the magnetic core and produces an output voltage which is proportional to the displacement of the beam. The output of the LVDT is connected to the intranet data acquisition system, and the voltage is related to displacement recorded by the computer. All data readings will be stored by the computer in Excel format. For the LVDT being used in this experiment, the voltage versus deflection calibration is 10 volts to 0.5 inches. So in this experiment, the software will be given results in voltage, and you'll have to convert that into inches by representing 10 volts to 0.5 inches. To recap the apparatus components, we have our power supply, which supplies voltage to our LVDT, and we have a clamp and stand that keeps our LVDT in place. We have a cantilever beam, and we have weights of 100 grams each, and we have 6 of them, which will be applied to the free end of the cantilever beam. The LVDT is then connected to our intranet data acquisition system, and from there the intranet is connected to our computer in voltage, and you'll have to use the calibration given previously to calculate your displacement. So to summarize the procedure, the LVDT is being wired directly to the intranet data acquisition system, and then we would position our shaft directly at the end of the cantilever beam, and we would check with our software to make sure readings are being transmitted, and we would also ensure that the displacement of the beam is being measured within the scale provided by the software, which is this scale that I'm referring to. After configuration is complete, we would then apply 6 loads, each weighing 100 grams. And on each load application, we'll be saving the recorded voltage on the software. So with that being said, let's begin the experiment. So this is a close-up of the power supply, which supplies AC power to the LVDT, and the LVDT is then connected to our intranet data acquisition system, and our acquisition system is then connected to our CPU, which gives us our voltage output reading on the software. Now that the system is configured and we have already recorded our 0 value, and this red line indicates our 0 value, we will begin by applying our first load. So we'll apply the first load of 100 grams. Then we would hit start to get our new readings. And we would go ahead and save as 100 grams. Then we would apply our second load, bringing it up to 200 grams. Let's start, save, 200 grams. Then we would apply the third load, bring it up to 300 grams. Hit start, new values, save, 300 grams. Then we would apply our fourth load, bringing it up to 400 grams. New value. And as you can observe, as the load increases, you can see deflection being observed. Save, and we're at now 500 grams. And at this point, we'll apply our last load, bringing it to a maximum of 600 grams, and we would save. So at this point, we have collected 6 different data readings. And as we said before, it will be represented as voltage, and you'll be using your calibrations to convert those voltage readings to displacement. So the experiment is complete. Your data will be supplied by your professor. Thank you.